Welcome to week 4 of GEOG473 673 Advanced R. This week is about spatial ggplotting. So last week we introduced ggplot2 and saw that it's a pretty sweet visualization package that can help really customize a ton of different plotting mechanisms for data frames in R. This week we're going to learn how to plot spatial features such as rasters or just different spatial projected data maps onto ggplot2 instances. So I'm going to click the week 4 link and it'll direct us to spatial plots with ggplot2. So this chapter we're really going to focus on mapping. First we'll work into a map of Australia, and then we'll take that, what we learned up here in this mapping exercise, to plot sea surface temperature with ggplot and ultimately add a map to that. And then we'll enhance this map by using a custom color bar that we'll create, and then talk about the assignment. So there are a couple different functions that ggplot has that will allow you to plot a raster or a spatial feature or a map or anything with a coordinate projection onto a ggplot instance. Some of these functions include geom_sf, coord_sf, geom_raster, stcrs. So there's a couple different functions right off the bat that we can use. So the main one that we want to look at here real quick is geom_sf. So that we're adding a simple feature geometry. SF is short for simple feature. So we're adding that to a ggplot. Simple feature is an R package. So SF is its own package. It's the simple features package, and it is a great package for reading in spatial data. So let's go ahead, let's load this package, the simple features package, and let's load OZ maps. You'll probably have to install both of these. So go ahead and install packages on both of these while we wait. So here, let me switch this around real quick. All right, so I'm going to load up my Oz maps and my simple features. And what we're going to do is we're going to load in the Oz states. So Oz is a nickname for Australia, and so we're going to load in OZ states or Oz states, right? So we have Oz states right here, and we have right off the bat we have a tibble table of these geometry for these different states within Australia. So if we run a class on OZ states, it is a simple feature, it is a tibble data frame, it's a tibble table, and a data frame. So it has multiple classes, which is good because we can use R to recognize this particular object as any of these classes. So now what we can do is we can just use this data, use this geometry data, and we can plug it into ggplot2, and then we can add in a simple feature geometry and a coordinate of a simple feature to that ggplot instance. And boom, there we have it. I mean, this is just a rectilinear grid of the different states of Australia. And just to show you what it would look like without the coord_sf, we just wanted the geom_sf. So it's automatically using those geometries, and coord_sf just kind of adds in some coordinates if they weren't already there. So luckily they're already here within this geometry. We don't technically need coord_sf. We'll see how this can be used later. So what we can do here is, right, so we have all this geometry data. It basically says how and where the edges of these polygons exist. So, I mean, none of these are going to be perfect squares, but if they were, you would just have 4 points, right? And that would be your geometry, be the corners, so to speak, of that square. This is obviously a lot more complex, so the geometries of each of these different states has a ton of different coordinate points. And the coordinates here are just lat long on a Cartesian grid, so just a rectilinear grid. So what we can do is we can use the aesthetics of GeoMSF. We can provide the data, so we have our data frame Oz states, and we're going to map it using the aesthetics of fill based on the name. So right here we see in this data frame we have name and we have geometry of Oz states. We're going to fill the map based on the name. Cool. Now we have colors and a legend for each of the different Australian states. So all we had to do was use the fill. We wanted to fill each of these by name, and you could actually customize the colors to whatever you wanted. These are just default and from ggplot. So this function chord_sf we saw doesn't do really anything right now because GeoMSF already has all of this coordinated for us. We already saw that we have a bounding box and we have a projection right here. It's a coordinate reference system. So this is GDA94. That is the projection of this. So it's already kind of doing a whole bunch for us, but we can use chord_sf to reproject things for us. So chord_sf, if nothing is in there, it's automatically assuming that we want the projection of long lat, or longitude latitude, just a very basic flat projection. Let's say we wanted to use mole wide. This is the CRS here, the coordinate reference system. It's the code. This is the Proj4 projection code right here that we can plug in as this coordinate reference system in the chord_sf function. So that's going to reproject this on the fly. Boom. Now we're actually on a mole-wide projection. And the only other thing that we added here was a title. So Oz states projected to mole-wide. And remember, this is done on the fly. This isn't doing anything to the initial data set. So yeah, that chord_sf can be used really on the fly right there, but we can also just use a straight up EPSG code. So we use the Proj4 string right here. This is a projection string. But remember, a lot of these coordinate reference systems, they have Proj4 strings and they also have codes to identify them. So we can use the stcrs function to use EPSG code 3112. And there you have it. So now we're using this EPSG and we're reprojecting on the fly right here. We can also cut things out, right? So using chord_sf, we can actually use this to put our xlim and ylim within this. Now, why is this important? Why does this have to be used in here? Because we're in a latitude-longitude projection. Chord_sf is going to basically translate that data for us. So if we provide x limit and y limit in the terms of latitudes and longitudes, chord_sf is going to translate that to the data set for us and say, okay, I want this particular slice, this little window right here. So we can use that, and then what we're going to do is we're going to add in this label right here, GeoMSF label. So we're adding the simple feature label, and that label is equal to the name column of the data set. So we're just going to zoom in all on Tasmania right here. So yeah, pretty cool, pretty easy to do anything with the spatial data set in ggplot, and it's really the simple features package that makes things easy for us. So now we're going to take these tools we've learned up here, we're going to apply it to a sea surface temperature data set. The data set that we're going to use is like all the rest have been. It's part of the datasets folder, and it's going to be it's going to be called Goes Are Rolling One Day. So what this is average sea surface temperature for a daily period, and the day is August 14th, 2019. So what we're going to do, we're going to bring in our packages that we need, and we're going to use a couple different packages here, so you might have to install a few. So we're going to load map proj, map tools, raster, raster viz, our color brewer. So we're going to load all these ones up. And from here, what we're going to do is we're going to read in this netcdf file straight as a raster. We're not going to read it in as a netcdf file first. We're going to read it straight as a raster, right? So for me, my netcdf file of goes are rolling one day is located in my datasets folder, blah, 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 this whole string right here. So I'm going to run it, just read it in straight up as a raster. So there we go. So we read it in, and this works because we have SST as our variable. It's our only variable, so that's why this works without declaring a band. And we have our CRS information, we have an extent, so on and so forth. So we're going to crop that to -100 to -80 longitude and 16 to 30 latitude. So really we're just focusing on the Gulf of Mexico right here. So that's what we did right there with the crop tool. And now what we need to do before we actually use this raster within ggplot is we need to convert it to a data frame. Why? Because ggplot is designed to work within data frames. So what this did is it basically took our nice two-dimensional image, and so let's just image SST rast really quick so you can get a feel for how it is. Here's Gulf of Mexico, here's the Yucatan Peninsula, here's Florida, here's sea surface temperature. So it took this 2D grid that looks really nice and is geolocated, and it basically extracted it point by point into a XY temperature. So X -90, Y 22 temperature value. I put it in a data frame that is column based. So I have this super long data frame now. It's 859,000 rows long. But ggplot2 knows how to work with that really well. So now what we can do is we can use the geom raster function with our data frame df. Really, it's a raster that's been converted to a data frame. Boom, there we go. Now we have a ggplot instance right here of our data. So, looks the exact same pretty much as this quick image function, only now we're in ggplot. So we know we're geolocated correctly. Again, here's Florida, here's the Yucatan Peninsula. All looks good. So everything looks good here. We have a CRS, which, is all good. It all looks good. But one thing we notice here is we have a Y and an X right here. So something's not being translated. What we actually want to do here is we're going to translate, because this is just a plain old data frame. It's not a simple feature data frame. It's not a Tibble data frame. It's just a plain old data frame. It has no CRS information. But the SST rast has CRS information. So what we need to do is we need to translate the information that's within the raster to ggplot2, because the data frame can't store that. So what we're going to do is we're going to plug in that CRS down here into chord SF. What that's going to do is just going to geo-coordinate everything for us. Now, instead of X and Y, why did that not work? So now, instead of just having these random numbers out here that's like 30, 28, now it's 30 degrees north, 16 degrees north, 100 degrees west, 80 degrees west. So that's all that function is really doing, is it's coordinating, it's geolocated everything. The reason that it doesn't change anything to the projection is because we're already in a lat long projection. Now, everything is geolocated, everything looks all good. And now that everything is geo-referenced, we can actually kind of play around with some coloring a little bit more, and we actually we aren't constricted necessarily to this chord SF. We can actually use chord quick map, which it just enhances the speed of things, and what it's doing is it's actually approximating geolocated lines instead of doing it exactly. So that's all chord quick map is doing. It's just, it's kind of cutting corners. But the reason that you might want to do that is because it leads to faster plotting. The other thing we're going to use here in conjunction with this chord quick map is we're going to add this function in called scale fill gradient n. Now, what this is, we're going to add a gradient, a color gradient in here, and that color gradient is going to be our jet colors. So we're going to use, this is all from the package that we loaded in way back up here called our color brewer. Now, what we're going to do is we're going to use this color ramp palette. We're going to give it specific colors. Now, our color brewer can read colors via hex code, which is what this is, or just the actual named color. So we're going to make a color palette, and it's just going to, this is going to say, okay, these are our main colors. Now, what I want you to do via this scale fill gradient n is I want you to blend all of these colors together. Your limits are 28 to 33 because we're in units of Celsius, so that the actual data is coming 28 degrees Celsius, or 33 degrees Celsius is our maxes. So that's what scale fill gradient n is. We're going to say, here's your initial colors, blend them together with these limits. And ultimately, you're going to see that this map process is a little bit faster than the last one. And we have our custom gradient color scheme right here. So yeah, it makes sense. I guess, kind of. I mean, you could assume that the only reason that it's a little bit colder here is maybe there's a storm system that just moved in. Maybe there's some rain, some freshwater rain that's going to cool off this coastal waters right here, because otherwise it would be a little bit warmer along the coast, you would assume. But anyway, the next thing we want to work on here is we just kind of have these very blank states right now. So, or countries or states if you're looking at Florida. So we have these blank color maps, right? And what we want to do is we actually want to work on filling those in with state boundaries or country boundaries. This is actually pretty easy. We've done this before in previous earlier introduction to our examples, but we haven't yet done it with ggplot, but it's actually not too bad. It's actually not too difficult. And what we're actually going to find is that we can do that using this borders function. So it's a ggplot function, and all it is going to add in country borders for us, which is really nice and really easy, especially when you're working with sea surface temperature data like this one. So all we're going to do is add this function in. We add in our x limits, our y limits, and it's the same limits that we've been working with for chord quick map or for chord SF. We're going to fill it in with white coloring. And again, borders is just a ggplot function. And there we go. Now, the last thing that we want to do here before we move to custom coloring is there's this extra stuff going on around the edges that we don't really care about. Like, I mean, if it goes, we have this kind of extra paneling out here. Let's get rid of it. So what we're going to use here is in chord quick map down here, we're just going to add this argument expand equals false. That's all we're going to do. So I'm just going to add this in over here to chord quick map, and it's just going to limit that panel expansion. So now we just have our window of data. So the last thing that we want to do here for this tutorial on spatial ggplot is we want to use our own custom color ramp And in this case, we want to use reds. So what you can actually do is you can display all these pre-made color palettes, right? So if you don't want to make your own, we can use some of these pre-made ones. So let's take a look at the reds. Now, what we can do here, or we can take a look at what the tutorial is, which is yellow, orange, red. So instead of reds, doesn't matter, whichever one you use, we're going to use yellow, orange, red instead of reds. Anyway, what we're going to do is we're going to use a couple helper objects. We're going to use brewer pal for brewer palette. We're going to say we want 9 different colors from the yellow, orange, red right here. And why 9? Because the maximum number of colors in the palette there's 9 different colors here. Yellow, orange, red has 1, 2, 3, 9 different colors. Now remember what all this is doing. It's not going to make a sequential plot of 9 colors. What we're going to do is we're going to blend those colors together. So we use pal right here to create a color ramp palette using those colors called pal. And what pal is it's just a function for finding these different blended colors between our main 9 from yellow, orange, red. And basically what we're going to do is we're going to add 20 colors in between each of them. So pal is a function where we are going to define in here the colors is equal to pal 20, and that's just saying we want 20 different colors to be between each of these 9 colors. And then all we're doing is we're just plugging in that value. Instead of jet colors, we're just going to have pal. And boom, so we just created this plot using this initial color bar right here. And there we go. The last thing we're going to touch on is not color related, but it's whenever you want to do a multi-plot in ggplots. We talked about this before where we have these graphical parameters with par, and if we're using a base plot, we can use multiple plots using the mfro, redefining mfro. In ggplot, it's a little bit different, and we can actually use a function called a package called grid, and its cousin function grid extra. Now, what this is going to do is it's going to, if we want to make two different plots right here, we'll just name them P1 and P2. If I print P1, it's the left side of the Gulf, kind of zoomed in right along the Yucatan Peninsula and Texas. P2 is the east side of the Gulf. So more Florida and Cuba. But if we really wanted to plot them side by side, we can do that using grid arrange. And this is from the grid extra and grid packages. And all this is going to do is we're going to say, okay, take our P1 and our P2, and we want 2 columns, 1 row. So arrange them, please. Boom. Almost looks like our first normal plot where we didn't cut it, but you notice the Y right here. And this is just showing how you can turn one ggplot, or you can split up a ggplot window into multiple ggplot instances. So for the assignment, we're going to practice these skills here using the treecove.nc dataset from the datasets folder. This is a tree cover percentage dataset. It basically has details on the tree cover percentage for the entire globe. It's based on percentage, it's 0 to 100. So for South America and Africa, plot the tree cover variable using ggplot2. Use a green color theme from our color brewer and add borders. So this is what you want one part of it to look like, just covered over South America, the other one to be centered over Africa, and plot these 2 plots next to each other using grid arrange like we just did up here. So now we have these 2 plots side by side, and it's just South American tree cover percentage against African tree cover percentage. So we just get an idea of the forested regions versus non-forested regions. When you're done, submit the resulting plots to Canvas.